Hello everyone. In this video, we will try to construct a astable multivibrator using IC555 timer. So for doing this experiment, we required apparatus or basically the components. First of all, 555 timer IC, a DC voltage source of 5 volt, two resistors, one of 10 kilo ohm and another of 100 kilo ohm, two capacitor, one of 1 microfarad and another of 0.1 microfarad, and a LED bulb, and also we required a oscilloscope. So before the starting the connection, we will explore about 555 timer. So 555 timer is the most versatile linear integrated circuit which can produce accurate and highly stable time delay, and this can be used for making monostable multivibrator and astable multivibrator. So basically astable multivibrator is a free running circuit which can take its states, means 0 to 1 or 1 to 0, that is higher to lower or lower to higher output without any external triggering. So here we can see the pin diagram of 555 IC timer, which has the 8 pins. The first pin is ground, where the ground is connected and all the voltages are measured with respect to this. Second pin is trigger pin, at this trigger input is applied, and third pin is output, from where output is taken. Fourth pin is used for reset, generally it is used for reset the IC, and fifth pin is used for control voltage, that is a control voltage. Sixth pin is threshold, seventh is discharge, and eighth pin is for positive supply voltage. So now we will look up that what's inside this IC. So basically this IC consists of four major parts. First is the voltage divider circuit. Here we can see that the trigger input, threshold, ground and positive supply is connected to this section, which is basically our voltage divider circuit. And the second part is the comparator. It consists of two comparators, and third is flip-flop, and fourth is transistor. So these are the four basic components inside the 555 timer. Now we will discuss about 555 timer as a stable multivibrator. So as we know that a multivibrator is a free running circuit in which there is no any external trigger is required to change the state of output, hence it is also called free running multivibrator. So for making a multivibrator using a 555 timer, this is the circuit diagram. Here we use resistor R1, R2 and capacitor C1 to change the voltage, or basically to change the frequency of the output, and capacitor C that is connected to pin 5 is basically used for reducing the noise. And since this is the configuration of a astable multivibrator, hence pin 2 and 6 are shorted together and we take output from 3. So here in this graphical representation we can see that when the capacitor charges, then we get the voltage level high, and when capacitor discharges we get voltage level low, and this process continues, and hence we get a unstable output, that is the 0 and 1, and continuously a free running circuit. So now the time of the output can be controlled with the help of resistor. Here we can see that this is the time which is required for charging the capacitor, and this is the time which is for discharging the capacitor. So basically here we can see that the charging time is always greater than that of discharging time. Hence the positive going pulse is always greater than the negative going pulse, hence we can't get duty cycle 50%. So here this is the formula for calculating the duty cycle, which mainly depend upon the combination of resistor that we are using, and we can also get the frequency of the output with this formula. And here also the output frequency is also depend upon the combination of resistors and capacitor. So now we will connect our circuit and make a stable multivibrator using 555 timer. Now we will start the connection. So first of all, since we are making a stable multivibrator, hence the threshold pin is short circuited with the trigger pin, and they are connected with a capacitor of value 1 microfarad, and another terminal of capacitor is grounded. Now we will connect the ground pin, that is pin 1, to the ground, and now we will connect the control voltage to 0.1 microfarad capacitor in order to reduce the noise in the circuit. Now the 100 kilo ohm resistor are connected with the threshold terminal, that is the 6th pin number, and its next terminal is connected to the discharge. And now the 100 kilo ohm resistor are connected with this terminal with the resistors 1, and it is connected to the positive power supply. The positive power supply is again connected to the VCC source, that is the pin number 8, and reset signal are also connected with the positive source in order to avoid false triggering. Now the output is connected to the one of the terminal of the bulb. Next terminal of the bulb is connected to the ground. Now for the showing the wave of input and output, we will use the oscilloscope. So we will connect the negative terminal of oscilloscope to the ground, and now channel A is connected to the input terminal, that is this capacitor point, and channel B is connected to the output. So this is our connection. Now we will start this connection and see the output. So as we start the circuit or switch on the circuit, we can see here the bulb start blinking after a regular interval of time. So now we can see this output in the waveform also in the oscilloscope. So here we can see that first of all, capacitor start charging. In this case, in this segment, we will get output as a high. As soon as capacitor get fully charged, then start discharging, and in this interval we will get low output. Again, when capacitor start charging, we will get a high output, and then in the case of discharging segment, we will get low out. This pulse keep on continuing, and whose time of charging and discharging basically depends upon our combination of resistor and capacitor what we have used. Basically this is the Astable multivibrator what we have made with the help of a 555 timer. But in this case we can easily visualize that the time of charging is always greater than the time of discharging. So here we can see that the positive pulse is wider than the negative pulse. So in this case we will not get, so we can't get the 50% duty cycle. So here in this combination we have used the resistor R1 of 10 kilo ohm, resistor 2 R2 of 100 kilo ohm, and capacitor of 1 microfarad, and using our formula we can calculate the frequency of 6.85 hertz. Now we can change this combination of resistor and also change the timing. For example, here we have used the 1 microfarad. Now we will use 0.1 microfarad capacitor, and we will verify our output. Now as soon as we will replace this 1 microfarad capacitor with 0.1 microfarad capacitor, we can see that the bulb is blinking in faster rate, that is the charging and discharging time has decreased, and we can easily see this in our oscilloscope also, that the time of charging and discharging is decreased, that is the pulse are forming at the faster interval than the earlier. So similarly, by changing the different combination of resistor R1, R2 and capacitor C1, we can get output of a desired frequency. So this is all about our Astable multivibrator using 555 timer. So Astable multivibrator can be used for making the frequency modulator or ramp generator or a firing circuit for our SCR set. In this case we have a problem that we can't get a 50% duty cycle. That's why now we will make a Astable multivibrator using operational amplifier. So now we will make a multivibrator using operational amplifier, that is the help of IC 740. So for this connection we required a IC 740, positive biasing voltage, negative biasing voltage, capacitor of value 0.1 microfarad, two resistors of 35 and 30 kilo ohm for making a voltage divider circuit, and another feedback resistor of value 50 kilo ohm. And also we required a oscilloscope for showing the waveform that are formed in the circuit. So before start connection, we will look up the circuit diagram of a multivibrator by using operational amplifier. So this is the circuit diagram for making a astable multivibrator using a operational amplifier, in which input signal are fed to the inverting terminal, and at the non-inverting terminal is connected to a voltage divider circuit. That is, the voltage provided at in non-inverting terminal is basically a reference voltage which depends upon the value of beta, and this beta depends upon the combination of resistor R1 and R2, and this is the simple formula for calculating the frequency. So in this case, basically a sinusoidal input from non-inverting terminal, we will get output as a we get the output in the form of discrete form, basically in the form of rectangular wave. And here the duty cycle, basically the time of charging and time of discharging is equal, hence the duty cycle obtained is of 50%. So for further more explanation and all the formula regarding the beta value, frequency and duty cycle, file is shared which is mentioned in the description, so visit that. So now we will start the connection. So first of all, we will connect the seventh terminal of op-amp to the positive biasing source and the fourth pin to the negative biasing source. And now we will connect the capacitor to the inverting terminal, that is at the pin 2, and second terminal of capacitor is grounded. Now, non-inverting terminal is basically connected to the voltage divider circuit. That is, the resistor of value 35 kilo ohm is connected to the resistor 30 kilo ohm, and they both are connected to the ground terminal. And this common point, basically between the resistor R1 and R2, is connected to the non-inverting input terminal. Now we will connect the feedback resistor from the output and the input, that is from the resistor of value 50 kilo ohm is connected at the pin 2, that is the inverting terminal, and output is connected to the second channel of oscilloscope, and this is also connected to the voltage divider circuit. And now we will connect the feedback resistor also to the output. Now we will connect the input coming from the capacitor to the first channel of the oscilloscope. Now the negative terminal of the oscilloscope is grounded. Now this is the entire connection for our multivibrator using operational amplifier. So as soon as we will switch on the circuit, we can see that initially after some delay the capacitor start charging and we will get a wave, and as soon as capacitor will charge in the charging period, we will get a higher output, and in the discharging period we will get a lower output. This wave continues as we have made a multivibrator, a stable multivibrator using operational amplifier. So in this case, now we can observe that in the positive going pulse, that is when capacitor is charging, then we get a higher output, and in the discharging case the output is at a low, but here the time of charging and time of discharging is same, means we can get the duty cycle of 50%. Now we can easily detect it by shifting our wave, that with these divisions we can see that the width of charging as width of discharging pulse is equal. Hence the problem that was occurring in the 555 timer, that is the 50% duty cycle, which we have achieved in the multivibrator using operational amplifier. So this is all about our connection and output of a stable multivibrator using 555 timer and operational amplifier. So that's all about the circuit. Thank you.